And welcome to Tensor Talks. Today we will be discussing about the roadmap of AML engineer or any AML domain. So let us start. Initially, we need a programming language that is either Python or R because these two languages are used in AML domain. Initially, we need Python. In the initial stages, you don't need to know about Python in depth. You just need to know about loops concept and object-oriented programming, that is OOPS. That's it for initial purpose. And next, if you want to go towards the research side, research in AML, you definitely have to know about the mathematics behind it. That is statistics, probability, derivations, and little bit of integrations also in some cases integrations. And if you want to go around development, yeah, you you need to know some little bit of mathematics. It is better to know mathematics. And next, we need to know about data visualizations. Without this, we can't move further because we need to know how the data is spreaded, and we need to know about how the standard deviation of this. And you will be knowing it in the mathematics statistics, standard deviation, mode, mean, median. Everything will be covered in mathematics. And data visualization techniques like we'll be using from some libraries like Matplot, Seaborn, etc. And after this, you are getting started around AI ML now. That is machine learning. So here, initially we'll be discussing about feature engineering, where we'll be discussing about outlier, how to remove the outliers, normalization, scaling, regularization, everything will be discussed here. And next, regression. We'll be discussing regression models like linear, multilinear, etc., etc. And then we'll be going around classification models. Next, classification model like support vector machines, SVMs, everything. Next, we'll be discussing about random forest, decision trees, and ensemble techniques, ensemble. And we'll be discussing about boosting techniques also, like XGBoost, AdaBoost, XGBoost, AdaBoost. This is the most important algorithms because these these algorithms are used in competitive natures. Like in when you go to the Kaggle competitions, the boosting techniques are used because it is very robust and it can outperform any algorithms that I listed above. And after this, machine learning will be completed, and then we'll be going around deep learning. In this, we'll be initially learning ANNs and then CNN. ANN is artificial neural network. Then CNN. This CNN will be used for images, mainly for images. Image data, the data which is present in the images, will be using CNNs, and then RNN. This for text recurrent neural networks, and then we'll be going around LSTMs, which are the memory, and GAN and auto encoders. We'll be discussing it later. After this, we'll be diving into some basics of NLP because this is needed for generative AI because basics like tokenization, stemming, lemmatization. These are very important when it comes to un when it- to understand the generative AI architectures. We need to understand these terminologies. So these are the NLP basics, and then we'll be diving into the most excited future domain, generative AI. Here we will be discussing about transformer architecture and then BERT architecture, GPT. GPT, like you know, Chat GPT. The GPT is known as generative pre-trained transformer. It is a transformer architecture which is trained on numerous data, like very numerous data. It's a terabytes in terabytes. But and then we will be going around some other like RAG, retrieval augmented generation. We will discuss it later when we come to there. And the most excited agentic AI. It will be the future. It will be the 2020, the 2025 will be moving around the agentic AI. In 2024, we have RAG and Transformer, and in 2025, the agentic AI will be going to rule. So this is the roadmap of AI ML, and yeah, this is enough for an AI engineer who is trying to crack a job in 2025. Let me explain what is ML in basic, just in basic. If you know in traditional coding, in traditional coding, we'll be giving an input and code, and the output will be displayed by passing the input to the code. This is known as traditional coding. This is the traditional coding. So when it comes to ML, we'll be giving input and output to the ML model. So this ML model will act as a code for the future data. Like you have trained, let us suppose you have trained on 100 samples. Let us suppose you have trained the ML model trained on 100 samples. Then from 101 sample, it will predict. The prediction will be measured using matrices like some score, like accuracy. The model accuracy will be dependent on the prediction. The prediction may be correct or wrong. If the model is very good, then the prediction will be super. That is, this is the ML. Like you will be giving input and output to the ML model. It will be training. Like for this input, the output will be this. For this input and output will be this. And after some epochs means like the number of times we'll be training on the data. So it will generalize the input and output behavior and see the patterns in it and acts as a code. Let us suppose you have y equal to mx plus c. You know this is the equation of the line. So y, let us suppose y is y y is height. So y is height. Wait a minute. So y is height and x is, oh sorry. Okay, y is height and x is weight. We know that height is dependent on weight. Like weight is dependent on height. So when your height is when you are very tall, your weight will be more compared to shorter person. This is how the model will get input as height and output as weight, and it will be calculating some slope and constant. Slope means Here in this we'll be calling the weight in machine learning and the constant. Don't worry, we will be discussing it in next video of linear regression, and you'll be amazed. Like we'll be having how the visualizations. You'll be very amazed after seeing that. Like you can see the linear regression in your mind. You can easily cope up with that. And yeah, that's it for this. And yeah, subscribe for the next videos